Hello, this is Mr. Stewart and going over the 3.3 homework quiz, which is about solving equations, and it's also covering additive inverse, using the additive inverse idea. So we're just going to get started on this. Remember, you can use calculators on this quiz, but ultimately, unless you're kind of, in a way, I should say this, I do not want you to use one of those cool apps online that solve equations for you without understanding how these work. So be cautious with that. Don't cheat yourself out of the learning experience. But we've got here, it says write the word sentence as an equation and then solve. The word sentence reads this: 5 less than a number, n, is -1. Now this is coming directly from the core. This is one of the objectives that the core has identified as a skill that we need students to have, is to be able to take word sentences and be able to put them in algebraic expressions and equations. So if you missed this question, I will explain what is happening here. When you say 5 less than the number n is -1. In fact, let me come up with my own example. Okay, I've just made my own example here. So it says 3 less than the number n is 8. You need to identify different components of this sentence. So 3, okay, that's one section of it. And then we would say less than a number. Okay, less than the number n, that's kind of another section. And then identify this, so is, and then the last section is, we would say 8. So 3 less than the number n is 8. Now, this is similar to this question over here, so just watch. And now again, if you're not, remember, you can skip to the question that you missed. You don't have to listen to the whole video, just skip to the question you missed. So if you missed this, as you're reading this, a very common mistake would be this. Students would think, okay, I'm going to do 3. And then less than, I know what that means. That means subtract. And then a number n, okay, subtract n, is, I know what it is equal to, and 8. Okay, now if you did this, this would be wrong. And let me tell you why. It has to do with the way the order things are worded here. When you say 3 less than a number n, this isn't saying 3 take away n. Let me read it like this. What is 3 less than 9? If I said 3 less than 9, well, what's 3 smaller than 9? Well, here's 9, here's take away 3, and that equals 6. I would say, so 3 less than 9 equals 6, right? 3 less than 9 is 6. Well, the only difference between this example and this example is that I don't know what n is equal to, but I do know that 3 less than that number is equal to 8. So what do we actually need to write here? Well, I've got a number n, and now I'm trying to figure out what is 3 less than n. I'm taking 3 away from n. 3 less than the number n is equal to 8. Now at this point, we're just using inverse operations. This is how you set it up. 3 less than the number n is equal to 8. I've got myself a nice, beautiful equation here. And now I can figure out, what does n have to be in order for this equation to be true? And I'm going to use inverse operations here. I'm going to use the additive inverse to be able to get n by itself. So I got to get 3 out of here. Right? And we'll kind of go into more detail in the next question, but remember the next part of this. So this question actually has 2 sections. You have to identify which one of these is true. And then from there, 2 of them look very similar. These 2 look similar. And these 2 look similar. So which one is the correct answer? Which one actually makes n true? So you're going to there's kind of 2 parts to this. So you're going to add 3 to both sides on my example to isolate the variable to get rid of 3. And that leaves n is equal to, what is 8 plus 3? 8, 9, 10, 11. So n must be equal to 11. Okay, so I'm going to move on to question number 2 now. Okay, this is where we're going to go in a little more detail as far as, that's actually a typo, I'll have to fix that later. But we're going into detail as far as how to solve for equations. So the first step is simple. It says, solve the equation for the unknown variable. That's supposed to say for, not for. And here's the equation. A minus 3 is equal to 13. And so what we're trying to figure out is what is A equal to? So it says, and this is important, please write the correct number that makes the equation true in the form. So in here you're just going to write the number. I don't know what it is, but let's just say 4. Okay, so don't write A is equal to 4. Okay, don't do a bunch of spaces. Just write the number 4 or whatever it happens to be. That's not the right answer, but you know, you're just writing the number in number form. That's all you're doing. Okay, so to kind of show you this, I'm going to make up another example. I'll just say A take away, I don't know, 8 is equal to 10. Right? Now, the easy way to go with this would just be say, okay, what number would make this true? And this is actually pretty easy to see. So for some of you might not be able to see this, but most students would be able to look at this and think, okay, the only number that works for A has to be 18. Because 18 take away 8 is equal to 10. And that's fine. That's totally okay. But we are trying to show you additive inverses, being able to isolate the variable using inverse operations. And the reason we're asking you to do this is because we need students to understand with more complex equations that to be able to isolate the variable. Because if you can't do that with simple equations, it's going to be very difficult to do with hard equations, and you'll get to a point where you won't be able to just look at the variable and think, the answer is 3/4. Like, you just won't be able to look at that and say that. So here's what we're going to do. Right, we've got ourselves a term here. We've got A, and we've got negative 8, and that is equal to a positive 10. Now the whole idea with equations is to isolate the variable. Here's the variable. Here's what I need to find. I want to isolate. And isolate, the word isolate means to get alone or to get it by itself. And actually I can start working with things here. Let's draw, we're going to draw this expression over here, okay? So over on this side of the equation, I'm going to draw 1a, okay, and 8 negative numbers. So just bear with me for a second. Okay, so there's 8, there's 1a and 8 negative numbers. So each one of these boxes is representing a number that's negative, a negative 1. All right, it's different than a because I don't know what a is equal to, but I know that these are each of them equal to 1, and I've got 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to put that's equal to, and on this box over here, I'm going to draw 10 positive numbers, okay? So 10 positive numbers. So give me just a second. Okay, so there's 10 positive numbers. So what we've got here is a perfectly balanced equation. I don't know what a is equal to, but whatever a is, whatever it's worth, I know that a and these negative 8 numbers here is equal to, is balanced with these positive 10 numbers over here. So the idea is to try to get these negative numbers out of there and find a way to figure out what a is equal to. Well, the only way to get a negative number away, or to get rid of a negative number, is to actually add a number to this. So if I add, so like if I look at, here's this negative 1 here. If I add one positive number to it, that's gonna take this, and they're gonna cancel out. All right. So if I add another one, that's gonna cancel out this one. And if I add another one, and 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 another one, that's 6, 7, 8. So 8 positives cancel out 8 negatives. Okay? But what happened here, since this was a perfectly balanced equation, it is now much more heavy on this side, right? So in order to keep it balanced, I have to also, whatever I put on this side that changed it, I have to also put the same amount on this side. So I have to go 1, 2, 3, 4, 5, 6, 7, 8 positive numbers. Okay, so these are all canceled out. They're gone. But to keep it balanced, I had to add 8 positive numbers to this side. Now I'm left with A is equal to whatever happens to be all over here, right? Which is, if you count them out, that's going to be, well, it's 18 positive numbers. And that's effectively what we're doing here. As I look at a negative 8, if I added 8 to this side of the equation, that's going to cancel this out. But in order to stay balanced, I have to add 8 to this side as well. And as you combine them now, 10 plus 8 is 18. And 18 is equal to, well, there you go. The A is now isolated, and A is equal to 18. I know this is a very lengthy process to show you, when really most of you could have done this in your head. But the idea is to show you the simple version of this, so that when I give you more complex equations, you already have the skills necessary to be able to isolate the variable and solve for the equation. Because you're going to get to a point where you won't be able to just look at it and go, oh, A is equal to that number. So take a look at that and make sure you're typing it in the correct format. We'll move on. Okay. Question number 3. Again, fill in the blanks. You just have to tell what C is equal to. Make sure you put the number in there. And really, let's just do one like quickly. Okay, this will just be super quick. So C take away, I don't know, let's do 3.3 is equal to a negative 8. Whatever. Right? So the whole goal, again, is to just isolate the variable. This is the variable you want by itself. Here's your balance beam. This right now is perfectly balanced between these two. And this is the point where it gets a little more challenging to think, okay, what does C have to be equal to in order for this to be true? It's a little bit more tricky to just come up with this in your head. But you can let the math do it for you. So we need to get rid of this negative 3.3. Right? It's bothering the C. It doesn't want. We need to get C by itself. So in order to get rid of a negative 3.3, I do the additive inverse, which is a positive 3.3. What happens when I take two numbers and add them together that are exact opposites? Goes to 0. But in order for this equation to remain true, I have to do the same thing to the other side. I have to. So whatever I did to one side, I had to do the other. Now I'm going to erase this, lest you think that that is division, because it's not division. Right? And I'm left with, let's see, this goes to 0, so I'm left with C, this comes down, is equal to, and what is a negative 8 plus a 3.3? And, you know, you could use a calculator for this, or we could just do this quickly. 8 subtract 3.3, the answer is going to be negative because 8 is farther away from 0 than positive 3.3. And here you go. Let's start here. Borrow from this. 10, take away 3. That's, 7. And the decimal comes down. And 7, so 3, 4, 5, 6, 7, 4. And my answer is a negative 4.7. Now, what I love about equations is there is no way you should get this question wrong. Here's why. Because once I get my answer, I can actually take this answer and substitute it back in for C and see if this actually works, if this is actually true. There's no way I should get this wrong, because as soon as I get the answer, I can actually prove that it's the correct answer by substituting it back in. So now, so this is my original equation. C minus 3 and 3/10 is equal to a negative 8. Now we just decided that C is actually equal to, negative 4 and 7/10. So instead of C, I'm going to replace that. I'm going to substitute that with negative 4 and 7/10. And now all I have to do is add them up and see, is this true? A negative plus a negative, all right, on the number line, a negative plus a negative, so that's going to take me further down the negative. And so 4 and 7/10 and a 3 and 3/10. So 3 plus 7, that's going to be a 10. Carry the 1. 4 plus 3 is 7, plus 1 is 8. And it's a negative because it's negative and negative, so negative 8 is the correct answer. So this is the true solution. So there's no way you should get this question wrong. Right? When you solve this one, whatever you get for C, plug it back in for the original equation and see if this is true. If it's true, then you got it right. If it's not, then you need to fix it because that's probably not the right answer, right? It has to be true. Okay, question number 4. Look, we can do these with fractions as well. This happens to be a multiple choice question, but that's okay. One really great thing about multiple choice, and this is just a good test-taking strategy, whenever you're given an equation and you're given a set of multiple choice questions, you could always just test each one to see which one makes the equation true. But let's not do that. Let's do it for reals the way we want. I'm just going to make one up, okay? Q plus 1/2 is equal to 1/3. I'll just make it simple, all right? Equation, fractions, decimals, integers, it doesn't matter. It's all the same thing. All these numbers are just numbers and we treat them all the same. Here's your equation. Let's see here. Actually, I'm going to do this. Here's your equation. All right, there's your balance beam right here. I need to get Q by itself, which means I'm going to do the inverse operation of a positive 1/2, which is going to be a negative 1/2. And whatever I do to one side, I have to do to the other. Got to keep things balanced. Additive inverses of each other goes to 0. I'm left with a Q. And now that's by itself. I've accomplished my goal. And now I just have to think, okay, what is 1/3 and a negative 1/2? That's all we're doing. So quickly I'm going to make this into, let's see, multiply by 2, that's going to be 2/6. And multiply by 3, so that's going to be 3/6. And now that equals negative 1/6. This is my solution, negative 1/6. I could take this answer, plug it back in for Q, and see if a negative 1/6 plus 1/2 actually equals 1/3. And you will find out, I believe, that is true. So that should work. You'll want to do this with your own evaluation on this side. Okay, getting kind of long here, so I'm just going to say this. Just make sure you're typing in correctly. Solve for the equation unknown variable. The equation reads a negative 19 7/10 is equal to D minus 7 1/10. What is D equal to? And then please write the correct number that makes this equation true in decimal form. So you're not going to want to write it in fraction form, but in decimal form. So I'll just make up a quick one that looks similar to this. I'll do a negative, let's see, negative 18 6/10 is equal to D and a minus 5 2/10. Okay. So just making this up so that you can kind of follow along and you can kind of look at how I solve this one and maybe hopefully try to apply it to the actual equation. A lot of students get confused or they sort of freeze up, I'll say this, whenever the variable's on the other side. But the variable doesn't matter what side it is on. All you have to identify is what operation is happening right here. How do I cancel a negative 5 2/10? What is the inverse operation of a negative 5 2/10? And the answer would be the opposite of negative 5 2/10 is a positive 5 2/10. And the opposite, so whatever I do on this side, I have to do to this side. And so inverse operations is what we call a zero pair. Goes away. I'm left with D is equal to, and the answer here, all I have to do is solve, okay, what is it, negative 18 6/10 plus 5 2/10. If you think about it on a number line, this negative 18 6/10 is taking me way down here. And this positive 5 2/10 is taking me a little bit in the positive direction, which is nice. But my answer is still going to be negative. So they're opposites, so they're going to be canceling each other out. So all I have to do is actually find the difference between them. So 6 take away 2 is 4, bring down the decimal. 8 take away 5 is 3. 1 take away 0 is 1. And I know that my answer is going to be negative. So I can say that D is equal to negative 13 and 4/10. Now that is my example. That is not your example. I didn't solve this. So if you just put this number in, that's definitely going to be wrong, right? So as you're watching this video, please understand this is my solution to the one I made up, not your solution. And you can always test this. Take this number, plug it back in for D, see if this actually makes it true. And I think you'll find out that it will. Anyway, I hope this is helpful for you. It's getting a little bit long, so I'm going to cut it off now. Hopefully, take the quiz again, take your time with it, and have fun.